Welcome to part B. Here we go. Determine the x-coordinate of the point at which G has an absolute maximum. So for absolute maximum, we're going to use the candidates test. For this one, I think there's different ways around this, but I always like to use the candidates test for any absolute extrema I'm used to it. So to use the candidates test to find out where a function G has a absolute max or min, you have to find the critical numbers, which means you have to find out where the derivative of the function equals 0. And then you have to, those would be some of the candidates, and then use the other candidates, the endpoints, and plug them all into the original function. So the first thing I'm going to do is find the critical numbers of G. So the critical numbers of G would be where the derivative equals 0. From the last video, we found that the derivative of G using the second fundamental theorem of calculus is this, and we have to find out where this equals 0. In other words, the critical numbers of G are where f of x equals -2. F of x is given, it's the graph. -2 is right here. So to find out where that is, the slope of this line is down 1, 2, 3, 4, 5, 6 over 1, 2, 3, -2. So if I want to, it's -2 over 1. If I want to get to find out where this graph is -2, the way I would do it is just start from here, where it's 0, go down 2, and over 1. So right here it was 1.5. So right here, it would be 2.5. So f of x equals -2. When x equals 2.5. So now I have all my candidates. I have the endpoints -4 and 3, and the critical number 2.5. So now I have to calculate all this. So here we go. So let me clear this out of the way and start. So my left endpoint is -4. And now you have to plug these into the original function G and then compare the values. So I have 2 times the -4, which is -8, times the integral from 0 to -4. So here's -4. You're going to just have to calculate all of the areas. We already said in the previous video that this is 9 over 4 pi, 1/4 pi r squared. And then this would be 1/4 pi r squared as well, but r is 1. So this would be just pi over 4, pi times 1 over 4. So this integral, since you're going from right to left, would be -9/4 pi plus pi over 4. So that's going to be -8 minus 2 pi. That takes care of that endpoint. Now we're going to do the critical number. So do the same thing. Plug in 2.5 for x. So 2 times 2.5 is 5. Plus the integral from 0 to 2.5 of f of t. So 5 plus. So now we're going from 0 to right here. So first triangle, 1/2. Base is 3/2 times height is 3. So that would be 9/4. And then subtract this other little triangle. triangle. Remember, we said this, we know that this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, and we know this is 2. So 1/2, 1 times 2 is -1. So we have 4 plus 9/4 there. So we can work with that. That's good. Now G of 3 is, now we're going to have to do this entire area. So if you plug 3 in for x, you get 2 times 3, which is 6, plus the integral from 0 to 3 of f of t. The integral from 0 to 3 is very nice because they cancel each other out. So this is just 6. So you can see that we have g of 3 is 6. We have g of 2.5 is going to be 4 plus 2.5, which is 6.5. That means we found a maximum. So to answer the question, the x-coordinate would be, for the maximum, is x equals 2.5. And that is proven by this candidates test. So that's it for B.